Hang on. Stand by.
Wait. Stop.
No, the correct response is my aircraft,
Your aircraft.
go round, toga, flaps 20,
Flaps 20, positive rate.
gear up, set missed approach altitude. Thanks, Pete.
Okay.
You're cleared off. It's Saturday, April 30th. My name's Juan Brown. You're watching the Blanco Lirio channel, and we have a very important update. The preliminary report on Air France 11 that had the botched go-around out of Charles de Gaulle, Paris, France airport back on 5 April. Remember on our first update, we had this exchange from the Air France pilots of Air France 11 published here on Air Live. This is the live ATC data, the live ATC conversation.
Wait. Stop.
There's the warning horn, the stop. At this point, the pilots are conducting a go-around. They've been lined up with the ILS 26 left. They wandered left, of course, and they initiated a go-around and began immediately fighting over the control of the aircraft between the two pilots.
Je vous rappelle.
Air France Hotel Whiskey, stoppez la montée 1500 pieds immédiatement. Air France Hotel Whiskey. Oui, on stoppe 1500 pieds.
Stop. Ok, France 011, on a remis les gaz, mais 4000 pieds, on va les maintenir, on vous rappelle.
Pas de soucis 011, maintenez 4000 pieds, le QNH est à 1013, le départ en dessous est stoppé, vous me rappelez quand vous pouvez.
The pilots performed the go-around and subsequently got the aircraft back under control and back on autopilot.
Air France 011, on a remis les gaz, donc un problème de commande de vol. L'avion a fait à peu près n'importe quoi, donc on est prêt à se reporter en finale avec un guidage radar. Le temps de gérer un petit peu la situation, si vous pouvez me donner une très longue vente arrière.
And then guide us in for the downwind. Remember, we went through the translation with Jenny that they had problems with the flight controls and the aircraft was doing... What was it doing, Jenny?
Who knows what? It was misbehaving.
And that the aircraft was doing who knows what. The aircraft was misbehaving. Now we have the data that explains exactly what these pilots were doing and how the aircraft was responding. Okay, here's a copy of the full report from the aviation source. On Tuesday, 5 April, the Boeing 777 registered Foxtrot Gulf Sierra Quebec Juliet, operated by Air France, was programmed to carry out a scheduled flight as Air France 11 between New York and Paris. Scheduled, in other words. 15 crew members, 2 flight crew, 13 cabin crew. Now, normally when we fly that route, we usually fly it with 3 pilots because on the way back to New York, it often exceeds 8 hours. So we have a third pilot. I'm usually the FB on a trip like that. But in this case, Air France is only running with 2 crew members. That means they're flying that trip without a break, without a crew rest break. 177 passengers were on board. Takeoff was at 0116 local, so I think that means 1 o'clock in the morning Paris time for these pilots. They would have had a 24-hour layover, I assume, in New York City before heading back to Paris. The captain in the left seat was the pilot monitoring, PM2. The co-pilot in the right seat was the pilot flying, PF3. During the descent, the crew prepared for an ILS 4 approach to runway 26 left. That should be this approach here. Minimums of 516 feet, minimum RVR 1,000 meters. The weather at the time was winds 230 at 8 knots, visibility 3,000 meters, cloud ceiling at only 300 feet, temperature 9 degrees, QNH, altimeter 1013. On final, the aircraft was established on the localizer and glide slope ILS beams. So it was IMC conditions all the way down to 300 feet but plenty of good visibility, fairly good visibility, 3,000 meters, well above minimums for the approach. At 0749, the crew was cleared to land. They configured the aircraft for landing. The selected speed was 140 knots. The crew then carried out the landing checklist at 0750-20 when the airplane was at an altitude of 1,670 feet. Remember, Paris, the altitude is about 392 feet. So 4, 5, 6, they're about 12 to 1,300 feet above the ground here. At 1,670 feet MSL, the pilot flying continued the approach in manual flight. He disconnected the autopilot, leaving the auto throttle and flight directors activated. And that's the normal configuration if you're going to hand fly an approach. You click off the autopilot, but you leave the auto throttles engaged and you follow the flight directors. So the co-pilot is electing to hand fly the aircraft in IMC conditions. He then made inputs on the controls for around 15 seconds. The airplane followed the movement of the controls and stayed on the ILS path, the left and right roll being less than 2 degrees, and we'll look at the data here in a minute. In the subsequent 10 seconds, there were fewer inputs on the wheel. The co-pilot then made inputs on the control column and wheel with a greater frequency. The amplitude was still small. The airplane followed the commands, the left and right roll being less than 3 degrees. And this is pretty typical when you kick off the autopilot. Even as a passenger, you'll notice this on final. The autopilot gets kicked off, and then the pilot starts jiggling the ailerons, for lack of a better terminology, but he'll start working the ailerons a little bit, and you'll feel the airplane kind of rock a little bit back and forth. They can kind of get themselves in a bit of a pilot-induced oscillation while they're trying to keep the wings level on approach. The co-pilot then made inputs on the control column and wheel with greater frequency. The amplitude was still small. The airplane followed the commands, and the left and right roll being less than 3 degrees. At 075106, the co-pilot expressed his astonishment with respect to the airplane's bank angle. The roll inputs were amplified, and the average position of the control wheel was about 6 degrees to the left. The airplane turned left. The aircraft is following the commands of the pilot. The airplane turned left with a small bank angle, and the captain voiced his surprise with respect to the deviation from the flight path. In other words, the co-pilot is flying the aircraft to the left of course. At 075112, when the airplane was at an altitude of 1,115 feet, again, subtract 400 feet from that to get the actual number of feet above the ground, the aircraft was banked 7 degrees to the left with the wheel oriented 16 degrees to the left. The crew carried out a go-around. So was this crew disoriented? They were getting left of course, and they did the right thing. They needed to go around. But they were left of course and continuing to deviate left of course. Up until the go-around, the flight path had remained within the operator stabilization criteria. In other words, they were still on a stabilized approach within a half a dot of the localizer and glide slope and on speed, fully configured. The recorded parameters show that the two pilots then simultaneously made inputs on the controls. As soon as they started the go-around, they began fighting over the controls of the aircraft between the two pilots, while manually flying the aircraft with the autopilot disconnected. In the following second, the position of the wheel reached a maximum value of 27 degrees to the left. 1 second later, the roll reached a maximum value, the actual roll of the aircraft, of 15 degrees to the left, and a nose-up attitude was 12 degrees. At 075116, the captain commented that the plane was going to the left. The control columns were then desynchronized for 14 seconds due to opposing forces. Okay, now this is something common to Boeing aircraft. Stand by. Even though the Boeing 777 is a modern fly-by-wire aircraft operated with the assistance of flight control computers, the control inputs to the Boeing 777 are similar to most all the Boeing aircraft, a very traditional yoke system that is interconnected left and right. So you can always feel what either A, the autopilot is doing as that autopilot input is fed back through the control column, and or B, what the other pilot is doing. So these two control yokes work together. They are interconnected. However, in the event of a jammed control column, there is a breakaway mechanism that allows you to break one control column separate from the other to regain control of the aircraft if in the event one control column were jammed. In this case, these guys fought so hard over this aircraft that they managed to disengage this mechanism and temporarily separate these two control columns in the pitch mode, in the up and down mode. Here's a drawing of the original patent sketch for this breakaway mechanism that is used in most all Boeing type aircraft now, where you can break away these two control columns in pitch mode. Now, I don't remember what the exact force is to make this breakaway system work, but I believe it's something on the order in excess of 40 pounds of force, a considerable amount of force, which explains why there was so much grunting and groaning going on in the cockpit, and the fact that the guys had inadvertently activated the push-to-talk switch, and all this mayhem was going out on to the radios. So some of you Boeing 777 maintainers, I'm sure you guys test this system. Of course, as pilots, we never test this system. I've never pushed so hard on a control column to break it loose. So some of you maintainers, can you tell us about the testing of this system and how many pounds of force it takes to break this system apart? And the way the report sounds, it sounds like this was only a temporary situation. Does this, once you break away the control column, if you get it back in, if you bring the two control columns back together, will the system re-engage and function normally again? Or once you break this system apart, does it remain apart until which time that you manually reset it on the ground? Of course, you can continue to fly the aircraft just fine. It's just that the two control columns would be separated for the rest of the flight. So when the pilot said we had a problem with the flight controls, yeah, they had a problem with the flight controls. They caused the problem with the flight controls by activating this breakout mechanism from fighting over the controls. Again, this is not the Boeing 777 system. This is just a sketch from the original patent of the concept of a breakaway system on a torque tube. When you first hit the toga button on the Boeing 777, you'll get about a 1,000 to 1,500 foot per minute rate of climb. A nice, gentle, easy to manage rate of climb. If you push the toga buttons twice in the Boeing 777, you're going to get maximum power, and that nose is really going to pitch up, especially after the end of a long flight where you're fairly light on your fuel load. So they hit the toga switches once and initiated the go-around and began fighting over the controls. The captain held the control column in a slightly nose-down position, while the co-pilot made several more pronounced nose-up inputs. 2 brief episodes of wheel desynchronization were also observed. At 07:51:20, the go-around switches were pushed again, increasing the thrust to the maximum thrust available. Now you're really going to start climbing. At 07:51:23, the pitch reached a maximum value of 24 degrees. That is the pitch of the aircraft, 24 degrees, which you can do at max thrust quite easily in order to maintain speed, as it's going to pitch to the speed for the go-around. At 07:51:25, the co-pilot called out positive climb and retracted the landing gear. The configuration warning was displayed and the associated oral warning sounded. That's what we heard on the ATC tapes, and as we assumed on the first video on this series, it turns out that's correct, that there's so much mayhem going on, they messed up the go-around procedure. The go-around procedure, remember, it is my aircraft, go-around, toga, flaps 20. You got to get flaps 20 first so that you don't actuate the gear warning horn. If you just retract the gear first before getting the flaps to 20, you're going to get this warning horn because you're not in a proper landing configuration. The two pilots continued to simultaneously make inputs on the controls. The captain made more pronounced nose down inputs for a few seconds. At 07:52:06, the captain was the sole person making inputs. The crew completed the go-around actions. The crew analyzed the situation without perceiving the antagonistic inputs made on the controls and the desynchronization of the control channels. A little lost in translation. They didn't notice that they were fighting over the controls so much that they had literally opened up the breakout mechanism on the torque tubes to the control columns. They considered that they could use the autopilot again and carry out a new approach. Good idea. The co-pilot became the pilot flying again. The captain informed the controller that there had been a problem with the flight controls and asked to join the final for runway 27 right, so they decided to move over to the north side of the airport. The approach and landing took place without further incident. The sustained input on the controls led to the push-to-talk button and the autopilot disconnect switch being involuntarily pressed, the latter action causing several activations of the associated warning, as we discussed earlier. No failure warning was activated during the occurrence. No anomaly was observed on the airplane. There was no failure of the aircraft. There was no problems with the aircraft. The warning horn that you heard was all crew induced. At this stage, the analysis of the parameters does not show inconsistencies, in particular between the movements of the control and the movements of the plane. In other words, the aircraft did exactly what it was told to do. The validation and the analysis of the parameters are continuing. Particular attention will be given to reproducing the force applied to the controls and to the relationship between these forces and the movements of the controls. In other words, they're going to test this breakout mechanism and find out how many pounds of force does it take to activate the breakout mechanism. It remains clear that more due diligence is going to be needed amongst pilots, especially in the approach stages. The BEA, that's the Bureau of Inquiries and Analysis, is hoping that this will be the only time an instance like this will happen, especially in the Air France fleet as well. Well, this is the second time now. Remember Air France 447? This is a very big deal. Two pilots fighting over control of the aircraft at the same time instead of clearly establishing who has control of the aircraft with the simple terminology, and this is a very high emphasis item in the simulators today. The first word out of your mouth is my aircraft in the event of any sort of emergency or even a go-around. For now, it is unclear what Air France will do with the pilots involved, but they will probably be either retrained or dismissed from the company due to safety concerns. Now let's take a quick look at the data. Okay, quick review of the data downloaded from the aircraft. First column is altitude. Altitude comes down just fine for the approach, stabilized, and then initiates a go-around, and the altitude climbs out normally. Roll angle of the aircraft, by the way, this line here is autopilot disconnect, and this line here is the go-around. Autopilot disconnect, you can begin to see the co-pilot start making his little inputs, which become a little bit larger at the point that they start the go-around. That's the aircraft roll angle. This third column is the wheel angle, the control column wheel angle. Green, this is the right control wheel angle. And as far as the roll control of the wheel, there's only a disagreement, a couple of disagreements right here and here, where the left wheel disagrees with the right wheel on the go-around. The pitch angle, the initial go-around with the first hit of the toga button gives you that 1,000 to 1,500 foot rate of climb, brought them up to about 12 degrees nose high, nice and controllable. Then they hit the toga button again and get max power, and that raises the pitch of the aircraft up to 24 degrees nose high. And then you can see a couple of oscillations as they get things back under control after the big nose pitch up. Now, here's where they separate the torque tube in the elevator department on the go around, shortly after the go around, here we see the right control column pulling up and the left control column pushing down. So here's where they disconnected the breakaway mechanism, and it appears that it reconnected or fairly well matched up fairly shortly after they began fighting so violently over the controls. And then the engine speeds, the engines were matched up just fine. So because this crew failed to follow standard operating procedures for 1, transfer of aircraft control, and 2, go-around procedures, this led to this very botched go-around attempt and a separation of the flight controls on Air France 11, the control column, that is, via the breakout mechanism. As we get more information on this, we'll keep you posted. Thanks so much for your support, especially over on Patreon, that make this channel possible. We'll see you here. My aircraft, go around, toga, flaps 20,
Flaps 20. And I forgot what to say.
positive rate.
Positive rate. Okay.
Gear up, set missed approach altitude.
Yeah, okay. It's...
You got to memorize that.
I know.
Take 2.
Yeah.